So now that we know that there is going to be a magnetic flux that cuts here, we want to know what is going to be the effect of that. Is there going to be any use or not out of it because of the magnetic flux that is cutting through the second coil? Is there is going to be any use? How do we tap that use? Turns out there is an important law that Michael Faraday, a very brilliant scientist, he hypothesized, in fact, that if a current produces a magnetic field, we know that current produces a magnetic field, that is Ampere's contribution, Ampere detected it, then would the converse be true? Meaning that can a magnetic field produce a current? It's a pretty ingenious, right? What is the cause and what is the effect? If something is the cause and that creates something, can that is being created create what is created it in the first place? Yeah. So the cause and the effect get swapped. Yeah. For example, if I have a B, for example, here, if you have a battery, there is a current that flows through the coil. This current is going to create a B field. The direction of the B field is going to be depending on the direction of the coil, direction of the coil, whether it is clockwise or counterclockwise. But then this is the source, and this becomes the effect. The B field becomes the effect. Now, if I bring in a new loop, which is my, let's say, RFID card, this is the RFID reader, and this could be the RFID card. When I bring this loop in, this magnetic field cutting through this loop will create a current here. That means it's going to create technically a potential energy across these 2 points, so that when you close the circuit, there is a current that flows through. That potential is called as EMF, electromotive force. Yeah, it's just a voltage. Yeah, it's called electromotive force. But the catch is, for that electromotive force to be created, the catch is it needs to be time varying. So that's something new that you guys are reading. Yeah. So far we know that the B field is a function of X, Y, and Z. It's a function of R, or it's a function of space. Yeah. We just say B is maybe X, Y, uh, X hat plus maybe Y square, Z hat. So it's only a function of space. That means it's a static magnetic field. Static means does not depend on time. Means no time dependence. But then when I say time varying, what do we mean by that? That means the B field is changing with time. So that means my B field is not only a position function of space, but it is also a function of time. It keeps changing with time. So once you have such, then the magnetic field is no more static. You call that to be dynamic. So opposite of static is dynamic, right? So do you want your, the economy has to be dynamic, right? It has to be changing. It shouldn't be static. So similarly, here the magnetic field, if it is dynamic, it can produce current in a closed loop. And that phenomenon is called as electromagnetic induction, which is what you will be doing in your lab 3, yeah, where you will have a certain bar magnet that is flowing through a coil, and as the magnet moves, the magnetic field is moving. Because of that, there will be a current induced in the coil. So you'll be able to measure that how much is the current and voltage. So Michael Faraday went on to experiment this hypothesis, and he figured it out that yes, indeed it is true that there will be a voltage across the two ends of the loop. It can either be a loop, or this can be a coil by itself as well. If it is a coil, it has n loops, and that is given as proportional to the rate of change, the time rate of change of the magnetic flux. So if the magnetic flux is not changing, that means if it is static, then the d by dt is going to be equal to 0. Whereas if it is dynamic, then the d by dt is not equal to 0. Anything that is static, right, constant in time, anything that is constant, you differentiate with respect to time, then that is going to be equal to 0, isn't it? It does not change with time, it's constant. So whenever it changes with time, then the d by dt is no more 0. And whenever it is no more 0, that would lead to a electromotive force, or it's a fancy way of saying potential or voltage. Huh? So what is this total flux that is changing? That depends on the B field that cuts this loop. Yeah. So we are not talking about this loop anymore. Yeah. Because that's the source and the B field has already been created. That's the source and the B field has already been created. So now it turns out that this flux is going to be nothing but this whole term is going to be the phi m, the flux that is cutting through the coil. Each one, every single loop of this coil. So the important thing for you to know is that there is a negative here, and that's the consequence of the Lenz's law. Yeah, that Lenz's law tells you that this electromotive force has to be negative. Why is it negative? We will see that in a moment, but the idea is this. There is certain magnetic field that creates a current. Now this current, it's going to have its own magnetic field, and the direction of its magnetic field should be opposite to the direction of the magnetic field that creates it in the first place. What do we mean by that? I have something that is creating me. So I create something that is already creating me, right? But it has to be counter to what is creating me, so that what is being created does not keep expanding. Yeah? There is a finite energy, it can't keep on increasing.